Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be showing you the improvements made in HSM in SolidCAM 2009. Now I'll open up this operation that I have here in HSM that I use for roughing. And let's take a look at some of the improvements that we've made here. In our first area, we'll first go into our tool. You'll note that in our tool field, the lead in and out feeds that were originally here are not here anymore. We actually merged them into our data field. This was always very confusing. Now we have everything in our tool data field for that particular operation. So for all the HSM operations, all our data for our feeds and speeds are exactly where they should be in that data field itself. In addition, if I were to go now into my passes area, you'll note that we have here a button called by target and by stock. What this does is very simple. If I have it by target, then my Z upper level will automatically be according to the target, with obviously including the floor offset. If I choose by stock, it'll take my stock material into account and then have my upper level automatically according to the stock plus the floor offset. In addition, we've made some changes in our link area. If we take a look at our link area and we'll go into our ramping, you'll note that we added a field here called use approach points. So if I had a drill operation from before, I can actually use that drill point to actually enter my part itself. Notice my start point will be at that drill point itself. Let's just do a quick save and calculate and then run our simulation. My tool will go directly into the point where that hole was and then work from that area itself. I'll speed this up a little and you'll see that in the next level the same thing will happen. It'll go directly to that hole point and mill exactly from that point itself. In addition, we've added some other options, and let's take a look over here in this finish operation that I've done in constant Z. If we take a look at our constraint boundaries, we have constraint boundaries by selected faces. Let's just take a quick look at the define. We've added in our selected faces area an offset to the selected faces. In other words, if I pick the selected faces, such as these that I show over here, I can have an offset to go actually past that area as well, not just stay on that selected faces. Now let's go down to our link area. In our leads, we've added an option called basic approaches. Before, when I did not have this option, what would happen is that it will actually go down on the part itself, and then when it finishes one level, it will continue on the surface to the next level. The basic horizontal approach allows us to actually approach each level from the outside and then retracting and then go down to the next level. Sometimes this is preferred over the other. If I were to do save and calculate and run my simulate, you'll see that each level, and I'll stop this right here, you'll see that each level it goes in, works that level and then goes out and then goes to the next level instead of going directly on the surface itself. Now something else that we've added in our passes area under adaptive step down is we have here an option called optimize Z level. What optimize Z level does is very simple. Let's say I'm going down a total of 20 millimeters and I'm going down every 5 millimeters. If I do not use the optimized Z level, it'll actually go down 5, 10, 15, 20. But many times what happens is when it does something like that, the calculation time is longer because it's looking to go down to that exact level. If I were to activate optimize Z level and then give it a factor, say 5, then what would happen is it will go down, say 5.05, then 9.0, 95, but my final cut will be 20. So it's not looking for that exact stop, and it'll go approximately to those first stops, making the calculation actually work quicker. This does not have any versatile effect on your cutting itself. It just makes your calculation time go quicker. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.